Okay, this is this is my this is my fourth attempt now. So my first video stopped here, right when I wrote this, I believe. So I gotta cover this again. So I'm gonna write this over again, and please pray for me for this to work the fourth time, because I'm going a little cuckoo over here, saying the same thing over and over again, 4 times. All right, so this is a radical function. Anything with the square root is a radical function. And we know this about radical function, that we cannot do the square root of a negative numbers. For example, like negative square root of negative 10 or square root of negative 4, right? So just write yourself a note: cannot have negative numbers under the radical. Okay, very important. I'm going to highlight this. Cannot have negative numbers under the radical. All right. Because of that, we want everything under the square root to be positive. So we want this function, 4 minus 3x, to be positive. So how do we write that? We write that at greater than or equal to 0, because everything greater than 0 is positive, right? From 0 and everything to the right is positive. And then we solve for x. So negative 4 to both sides. Okay, to get rid of negative 3, we divide by negative 3. But when we divide by negative 3, the symbol changes. The symbol flips from greater than or equal to less than or equal to. Repeat that again. Whenever you divide by a negative number or multiply by a negative number, when we're working with inequalities, the symbol flips. So negative 4 divided by negative 3 makes positive 4 over 3. And let's write that as a note. Flip. Why did I put a G there? Flip sign when multiply or divide by a negative number. Okay, so flip sign when you multiply or divide by a negative number. All right, so let's go back to the notation. So for set builder notation, x less than x less than 4/3. So the set of all x such that x is less than or equal to 4/3. So what does this mean? Well, if we put 4/3 into the equation, 4 minus 3 times 4/3, well, 3 times 4 is 12. 12 divided by 3 is 4. That's 4 minus 4, which is 0. It gives us to the 0. Anything greater than 4/3 is going to give us a bigger negative number than 4. So it'll be negative. So everything less than this number will give us 4 minus that number, okay? So it'll always be positive. So that's set builder notation. Let's do interval notation. So since we cannot pass 4/3, then we can do everything less than 4/3. So everything less to be negative infinity all the way up to 4/3, and we can't pass it anymore, right? We do not want to put a parenthesis sign here. We want to put a bracket here, because the bracket tells us that it is included, that we stop there at exactly at 4/3 and it's a part of the domain, okay? If we put a parenthesis here, that means that we stop there, but we don't include that endpoint. Okay, so we do include this endpoint. All right. Last example. F of x equals the square root of 3x plus 12 over x minus 5. We've done both of these already. We've done a radical already. We've done a function with a quotient. So we got to do both strategies here. So we got to check top and we got to check the bottom. So we got to check both strategies here. Check top, check bottom. So let's do the top. The top is a radical. We're going to do the same strategy here. We want the function inside to be positive. So we do everything greater than 0. And for the denominator, we know we do not want a denominator that gives us 0, because we cannot divide by 0. So we want to find that 0. So we do 5 minus x minus 5 equals 0. Let's solve for x on this side first. Minus 12 to both sides. We get negative 12. And then we divide by 3. negative 12 divided by 3 is negative 4. Negative 4. And notice that we did not flip the sign because we are dividing by positive 3. So don't flip the sign when it's positive. Over here, solve for x equals 5. So these are parameters with our domain. Let's set it up. Let's do set builder notation first. The set of x for all x is such that x is greater than or equal to negative 4 and x does not equal to 5, right? We don't want x to be 5. All right? So that's one way of writing the domain. The other way is doing interval notation. So we do not go past negative 4. So that means that we stop at negative 4. But we include it. It's a part of the domain because it's equal to. And we go all the way up to 5, right? Because 5 is telling us that there's something going on there. We don't include it. So we do an open parenthesis. Don't include it. But we don't stop because it's greater than, everything greater than negative 4. It means that we keep on going to the right. And so we continue from 5 all the way up to infinity because that's where it keeps on going. All right? That is the end of our notes on the 4 conditions that could happen. There could be definitely more conditions that could happen, but these are the things that can help us, strategies that can help us get through them. Okay? Our summary says, what domain notation do we prefer? Which one makes the most sense to us? Which one do we like? Write it down in this summary here. And then tell me why you like it. Okay? That is the end of the notes. This is my 4th attempt. And it's taken me 2 hours to do it. And I'm going a little cuckoo here, saying the same thing over again and writing the same old thing over again. So I'm hoping that this works. Crossing my fingers. Thank you so much. And this is part 2 of the first one. It was supposed to be one set of notes, but I got cut off, so I just want to continue from it. There's one more part to our notes, which is going to be the operation on function. So there's going to be another one coming out.